Okay, so the 7.3b notes, it's just kind of a refresher and maybe a shortened version, hopefully, of the last set of lessons in 7.3a. So if I give you one trig function, so this is what happens when I give a statement like this. So we have a given, all right? Sine theta equals 4/5. Remember, sine theta is equal to the opposite over the hypotenuse. So if I tell you that the sine of theta is equal to 4/5, that means that 4 is the opposite of the triangle and 5 is the hypotenuse of the triangle. So if I draw a triangle, a right triangle, and I give this to be theta, opposite is across is 4 and the hypotenuse is 5. Now that means that the third side has to be 3 because this is a Pythagorean triple of 3, 4, 5. Whoops. Triple 3, 4, 5 triangle. Okay, so the other piece of information is that theta is between 90 and 180 degrees. That means that if we're talking about between 90 and 180, here's 90, here's 180, that means that we're in quadrant 2. Remember, it's all students take calculus, so sine and cosecant would be the two positive functions, and cosine and secant. Come on now, my writing is not working. Cosine is negative, secant is negative, tangent is negative, and cotangent is negative. So all we need to do is look at the theta. Theta of sine theta was 4/5. Flip it for the reciprocal for cosecant. Cosine is adjacent over hypotenuse, so the adjacent of theta is 3/5. The secant is 5/3, but they're negative. Tangent is opposite over adjacent. So opposite is 4, adjacent is 3, and then reciprocate for cotangent. Okay? Easy enough, right? So for number 2, we have same thing, cosine of 5/13. All right, so there is my rule. That's my given statement. And the terminal side is in quadrant 4. All right, so if I draw my quadrant 4, all students take calculus. Here we are, that's cosine, and it's reciprocal of secant. Those are your positive functions. So we're going to draw our right triangle. We have a cosine, so here's theta. I'm just going to put it there. Cosine is adjacent over hypotenuse, and if that's 5/13, then the adjacent is 13. No, sorry. The adjacent is 5, and the hypotenuse is 13, which means this is another special triangle, or a Pythagorean triple, is a 5, 12, 13. You could also use the Pythagorean theorem to verify, but 5 squared plus x squared equals 13 squared. And so you get 25 plus x squared equals 169. X squared is 144. And when you square root, you get x equals 12. Okay, but knowing the triple is faster. Okay, so now we are in quadrant 4. Cosine and secant are my positives, which means that sine, cosecant, tangent, and cotangent are my negatives. So now we just apply the ratios. So sine is equal to opposite over hypotenuse, 12/13, reciprocate. Cosine was given as 5 over 13, so secant is reciprocated at 13 over 5, and tangent is opposite over adjacent, and reciprocate for cotangent. Okay? All right. The quotient identity is tangent theta is equal to sine theta over cosine theta. So if I know sine and I know cosine, then I also know tangent. Okay, so given that the cosine theta equals -3/5 and that theta is in between 90 and 180. So 90 and 180. Here's 90, here's 180, so here we are in quadrant 2. All students take calculus. Sine is going to be positive. So I'm looking for sine theta, which is going to be positive something, and tangent theta is going to be negative because only sine is positive in quadrant 2. All right, cosine theta is 3/5. Cosine theta is adjacent over hypotenuse, which means that I get a -3 over 5. Disregard the sign for this case. I think it's easier just to work with the fact that we're looking at adjacent over hypotenuse. If I have a 3 and a 5, that means this must be 4. Okay, so the sine theta is, take it 4 over opposite over hypotenuse is 4/5. So now if I know sine theta and I know cosine theta, then that means I can easily get tangent theta by dividing them. Now, tangent theta also would be 4 over 3, but sine theta is 4/5. So if I use the sine over cosine is equal to 4/5 over -3/5. Well, that's equal to 4/5 times 5/3, because remember we flipped the second fraction, and let's make it negative. The 5's cancel, and there I have -4 over 3, which is what tangent is equal to. I don't think that's necessarily an easier way to do it. Honestly, I would have just used the triangle and done 4 over 3 to begin with, but that's another way, and we will use the quotient identity a little bit later. Okay, and then lastly, I think this is our last example. Yep, so now this is where the quotient identity might be a little bit more useful. So given that sine theta is equal to -√2 over 2. So sine is opposite over hypotenuse. Okay, so I know a triangle has an opposite of square root of 2 and a hypotenuse of 2 between 180 and 270. Well, here's 180 and here's 270, so that means we're in quadrant 3. All students take calculus, so T is tangent is positive. So tangent theta is going to be positive, which means that cosine theta is going to be negative. So if, sorry, I never put my theta in here. Here's theta. Oops. Here's theta. So here's my opposite. So my adjacent is unknown right now. So let's take x squared plus the square root of 2 squared is equal to 2 squared. And so I end up with 2 equals 4, and I still have x squared. So x squared equals 2. And then if we take the square root, we get x equals the square root of 2. So I actually have the square root of 2 over here as well. So cosine is -√2 adjacent over 2. Here's my adjacent, here's my hypotenuse. And tangent is opposite over adjacent, which is √2 over √2, which is just 1. And it's positive. Okay, that completes our lesson.